Welcome to The Explainer. Today, we are diving into the incredible life of a physicist whose story has it all: a Nobel Prize, a discovery that changed the world, and a quiet but really powerful stand against tyranny.
So let's just start with this question, because it's a wild one. Why would anyone dissolve a solid gold Nobel Prize medal in acid? It sounds like something straight out of a spy movie, right? But it's a true story. And it all starts with the owner of that medal, the German physicist Max von Laue.
Okay, so picture this. World War II. The Nazis have just invaded Denmark. A chemist named George de Hevesy has been trusted with the Nobel medals of von Laue and another German physicist. Now, trying to smuggle gold out of Nazi territory was a capital offense. Literally, you could be executed for it. So what does he do? He comes up with this brilliant, crazy plan. He dissolves the metals in aqua regia, this super corrosive acid, and turns them into an unremarkable-looking orange liquid on a shelf in his lab, hiding in plain sight. After the war, he just precipitated the gold back out of the solution, and the Nobel Society recast the metals. An incredible story. But to really get why von Laue was in this position in the first place, we have to go back to the discovery that earned him that prize.
So, long before he was a target of the Nazis, von Laue was this absolutely brilliant scientist who was about to completely change how we see the world. I mean, literally see it.
It's 1912, and von Laue is having a conversation with a colleague about how light interacts with crystals. And in the middle of this chat, he has this revolutionary idea. He thinks, what if we use something with a much smaller wavelength than visible light? What if we tried shooting X-rays through a crystal? He theorized that the atoms inside would scatter the X-rays in a predictable way. And that idea? Well, that led directly to the discovery of X-ray diffraction.
And here's the absolute genius of his breakthrough. See, visible light just bounces off stuff, but X-rays can pass right through. Von Laue realized that the perfectly spaced atoms inside a crystal would act like a kind of 3D diffraction grating. So as the X-rays went through, they'd create this unique pattern on a photographic plate, a pattern that was basically a direct map of the atoms inside. For the very first time, humanity could actually see the invisible architecture of matter itself.
And let me tell you, the scientific world knew how huge this was immediately. He was awarded the Nobel Prize for it just 2 years later, in 1914. This wasn't just some clever experiment, it was the birth of modern crystallography, a tool that is still absolutely essential in physics, chemistry, and biology today.
But von Laue's greatness, it turns out, wasn't just confined to the laboratory. As the Nazis rose to power in Germany, his incredible scientific integrity was matched by his personal moral courage.
He just flat out refused to stay silent while science was being twisted and corrupted by Nazi ideology. He saw the attacks on his friend, Albert Einstein, and this whole idea of German physics versus Jewish physics as completely and utterly absurd.
For von Laue, it all boiled down to this fundamental truth. He believed science was a universal human endeavor, something that should transcend all politics and nationalism. And he defended that principle, openly, even though it put him at great personal risk.
And his opposition wasn't just a one-time thing. It was this consistent, courageous pattern of defiance. In 1933, he gives a speech where he basically compares the Nazis attacking Einstein to the church persecuting Galileo. He single-handedly blocked a prominent Nazi scientist from getting into the prestigious Prussian Academy. And when the Jewish chemist Fritz Haber died in exile, von Laue not only wrote a glowing obituary, but then attended a memorial for him that the government had explicitly forbidden. Get this, he was one of only 2 professors who dared to show up.
You know, his resistance even showed up in these small, everyday ways. He would make a point of carrying parcels in both hands when he was out in public. Why? It gave him the perfect excuse for why he couldn't raise his arm for the compulsory Nazi salute. It was this quiet, clever, and powerful symbol of his dissent, something he did day after day.
So, after the war finally ended and the Nazi regime fell, von Laue, a man whose integrity was completely intact, took on the enormous task of rebuilding German science from the ashes. He got right to work. His international reputation and his moral authority made him the perfect person to reconnect Germany with the global scientific community. In fact, he was the only German invited to the very first big international crystallography conference after the war. He helped found the German Physical Society, reunify the National Physics Lab, and in this really touching move, he became the director of an institute and had it renamed in honor of his exiled friend, Fritz Haber.
But his life, this life marked by such intellectual brilliance and deep integrity, it came to a really tragic and sudden end.
While driving to his lab one day, his car was hit by a motorcyclist. He passed away from his injuries just 16 days later.
This was the epitaph he requested for himself. It's a final, quiet statement from a brilliant scientist who clearly saw no conflict between his reason and his faith. It just gives us a fuller picture of this incredible man. So, when you look back, the story of Max von Laue isn't just about physics, is it? It's a timeless reminder of the power of an individual's conscience. His life's work wasn't just in the patterns that X-rays revealed on a plate, but in the unwavering pattern of his own integrity. And it just leaves you wondering, what is the source of that kind of quiet, unwavering strength?